warm welcome to present hall. I am Yogeshwari, Assistant Professor, Department of Mathematics, Dr. SNS Rajalakshmi College of Arts and Science, Autonomous Coimbatore. Now I am taking about discrete structure and optimization techniques. Now the topic is northwest corner method. So first of all, what is transportation problem? We want to know about the transportation problem. A transportation problem is a specific type of linear programming problem that is called LPP. In this problem, we are asked to with transporting goods from several sources to various destinations. The goal is to minimize the goal cost of transportation considering the supply and demand at the source and destination points respectively. Transportation problems can be of two types: balanced transportation problems and unbalanced transportation problems. So northwest corner method, to find the initial feasible solution to the transportation problem, we can use northwest corner method. The following steps will guide you through the process of finding a feasible solution for a transportation problem using the northwest corner rule. Step 1, start with the top left cell, that northwest corner cell of the transportation matrix, assigning it at the minimum value of supply or demand, that is minimum supply or demand. Step 2, subtract the minimum value from the corresponding row and columns supply and demand. This can result in three possible scenarios. If the supply is 0, cross out the row and move down to the next cell. If the demand is 0, cross out that column and move right to the next cell. If both supply and demand are 0, cross out both the row and column and move diagonally to the next cell. Step 3, repeat these steps until all supply and demand values are 0. The question 1. So first of all, first question, get an initial basic feasible solutions to given transportation problem using northwest corner rule. So here it is, supply is 250, 300 and 400 is additional, and demand is 200, 225, 275 and 250. So this is most accordingly must equal to the supply and demand. We have the equal supply and demand. 400, 700 plus 250 is 950 and demand is also a 950. So this is called a balanced problem. Okay, solution. For the given transportation problem, total supply is 950 and the total demand is also 950. Thus the given problem is balanced transportation problem. Now we can proceed the northwest corner rule to find the initial feasible solution. Step 1, consider the upper left corner cell which has the value 11. The minimum value of the corresponding cell's supply and demand is 200. Step 2, the difference between the corresponding cells supply and demand from the minimum value obtained in the previous steps. Supply equal to 250 minus 200 is equal to 50. Demand equal to 200 minus 200 is 0. So as demand is 0, we need to allocate 200 to that cell and strike the corresponding column and then move right to the next cell. The cell with the value is 13. Step 3, for the cell with value 13, the minimum of supply and demand is minimum 50, 225. So equal to 50, we allocate only 50. The value is step 4, the difference between the corresponding cell supply and demand from the minimum value obtained in the previous step is supply equal to 50 minus 50 equal to 0, demand equal to 225 minus 50 equal to 175. So as the supply is 0, we need to allocate 50 to that cell and strike the corresponding column and then move down to the next cell, that is the cell with the value is 18. So next, first step 5, For the cell with the value 18, the minimum supply and demand is minimum 175. So that is the minimum value is 175. So step 6, the difference between the corresponding cell supply and demand, minimum value obtained in the previous step. Supply is 300 minus 175 equal to 125. Demand is 175 minus 175 equal to 0. So as the demand is 0, we need to allocate 175 to the cell strike in the corresponding column, and then move right to the next cell, that is the with the value 14. So this is throughout the steps by steps, one by one. These steps are including to until the answer is initial basic feasible solution is given. So throughout the initial basic calculate the initial basic feasible solution. So now we should calculate the total minimum cost using allocated values and the corresponding cell values. Here the transportation path is 0 1 D to D1, 0 1 to D2, 0 O2 to D2, and O2 to D3, O3 to D3, and O3 to D4. Therefore, the total cost 200 into 11, 50 into 13, 175 into 18, 125 into 14, plus 150 into 13, 250 into 10. So we want to add all the values. So the rupees is 12,200 is our transportation cost. Thank you.